Okay, good morning, afternoon, or evening. Welcome to Mr. Moore's Algebra 1 and 2 class. We're going to continue on factoring polynomials. Extremely important. You're going to use this pretty much for the rest of your mathematical careers. You're going to be factoring a lot, all the way through calculus and calculus 2. You're going to be using factoring skills. So might as well learn them today. Just get them out of the way. Let's take great notes and let's focus, and you're going to see how easy I've made this, I think. All right, well, today we're factoring trinomials, and there's two types of trinomials that we can factor. And the first type of trinomial is factoring trinomials in the form of x squared plus bx plus c, whereby the coefficient of x squared is 1. Okay? When you don't see a coefficient in front of x squared, that means that it's a 1. That's what we're going to be working with today. Please mind you that b is greater than 0 here, and c is also greater than 0. Why? Because think about it. If I had x squared plus 0 times x plus 0, wouldn't that just equal x squared? How can you factor out a monomial? You can, right? There's nothing to factor, right? It's just one little term. So b and c have to be greater than 0. Greater than, not equal to. Let me go back on that. Not equal to, just greater than 0. And they could be less than 0 too, actually. Okay, so let's get right to it, because this is really simple. Just follow my procedures, I beg you. Number 1, setup. I see an x and an x. Let me explain why. This is x squared here that we're starting with, correct? In our setup, what I should really do, this is the square root of the first term. Okay? Now you may be thinking, what is he talking about? If I take the square root of x squared, it cancels, it's 1. Okay? So I'm taking the square root of that first term. Now, how does that apply to larger values? It's basically you take half of the exponent and you split up the variable into two different binomials. So if I had x to the 8th here, my setup would be x to the 4th, x to the 4th. If I had x to the 4th, if that was my first term, I'd have x squared, x squared. If I had x to the 50th, I would set it up as x to the 25, x to the 25. So you always look at your leading coefficients exponent, divide it by 2, and place it into 2 parentheses to start forming a polynomial. Bless you. Does that make sense so far? Yes, sir. If you have an odd, you can't use that. Thank you. Great question. Sir. Negative exponents aren't here yet. We're not there yet. Okay? Any other questions? These are great, valid questions. Sir. Like I just said, if it's an x to an odd number, you can't use this. Usually, what would happen is if it's odd, they'll have it like this. 11x cubed plus 11x squared plus 18x. What can I do in this case? Come on, guys. Factor out an x. Yes, we just learned that skill. And then you would have the polynomial, the trinomial, to try to see if you can factor that. If that exponent is odd, though, you either have to factor out an x, or you can't factor it like this. You have to use a different technique. Everyone with me so far? Okay, so number 1 for this, x and x. Done. Number 2, what times what equals the c value, but when added together is the b value? What times what is 18 in this case, but when added together is 11. If you know how to multiply, you're going to love this chapter. If you don't know how to multiply, you're not going to be too happy. I saw a hand here. Absolutely. 9 times 2 equals 18, and 9 plus 2 equals 11. So step 3, plug in your answers, and you're done. You just factored the trinomial. You just factored a trinomial. And trust me, we have nothing but practice today. And there's still another type to factor. Does that make sense? So you have your setup, then what times what equals C, but when added together is B. Plug those two in, you're done. Now, they're not always going to be positive and positive, okay? Sometimes you'll have two negatives, sometimes you'll have a positive and a negative, sometimes you'll have a negative and a positive. But these are sign patterns. If you memorize the below patterns, it helps you find the factored answer easier. If you know how to multiply, that's the easiest. But sometimes people will set up their setups with the given signs already to help them out. So for example, if I have x squared plus bx plus c, my setup is always going to be, there it is, x plus and x plus. Because when I have a positive and a positive, I'm going to have a positive and a positive given forever, for sure, 100%. Sir. Okay, the question was, when I put the 9 and 2, does it matter what order? Not in this case, because they were both positive. But let's say that I had a negative 9. I better put negative 9 and not switch it and put a negative 2. But no, it does not matter because of the commutative property of multiplication. Yes, sir. Come again, I don't understand what that means. So usually it's going to be 7. Usually the middle number will be 8. What's 1 times 7? 7. And what's 1 plus 7? 8. Okay. When the given trinomial is in the form of a of x squared plus bx minus c, you're going to have an x plus and an x minus. You're going to have an x plus and an x minus. And when the trinomial is given in the form of x squared minus bx minus c, your form will also be an x plus and an x minus. So if the c is negative or the b and the c are negative, you have an x plus and an x minus. And when the b is negative alone, when you have an x squared minus bx plus c and the b is negative alone, you're going to have an x minus, x minus. So it's either x plus when everything's positive. When the c is negative, it's x plus, x minus. When the b and c are negative, x plus, x minus. And when only the b is negative, that's an x minus, x minus. Now, let's show you how this works, because it's magic. Okay, we got my setup. What's the power here? 2. So this is going to be an r and an r. Does everyone understand that first awesome step? What would it be if this was an r to the 8? R to the 4, r to the 4. You guys with me? Okay, but it's not. It's r squared. So half of 2 is 1, so r and r. Everyone's with me? Okay, what times what equals 24, but when added together equals 11? Absolutely, 8 and 3, you're done. 8 times 3 is 24, 8 plus 3 is 11. Bye-bye. Okay, example 2, my setup, always my setup, y and y. Now look guys, pay attention to this. Only the b is negative. So according to what I just finished telling you, when the b is negative, this should be a negative and that should be a negative. What times what is positive 8, but when added together is negative 6? Negative 2 and negative 4. Done. It doesn't matter if you put the 4 here or here. Because, again, because of the commutative property of multiplication. That allows you to multiply in different orders. 5 times 6 is the same thing as 6 times 5. So y minus 2 times y minus 4 is the same thing as y minus 4 times y minus 2. Thank you, sir. Does that make sense here, guys? Negative 2 times negative 4 is positive 8. Negative 2 minus 4 is negative 6. It works. Okay, my setup, x and x. What times what is positive 24, but when added together is negative 11. Negative 8, negative 3. The b was negative, so both had to be negative in the polynomials, in the binomials. What times what is positive 2, but when added together is negative 1. No, not negative 1 and 2. Negative 2 and positive 1. What's negative 2 times 1? Oh, no, that's wrong. You're absolutely right. The b is negative. You're absolutely right. Whoa. Wait. No, I messed up here. This should have been, no, that doesn't work. So what do we call something when it doesn't work? Prime. Very good. Yeah, no, nothing times anything is 2, but when added together is negative 1. Nothing. If there was a negative 3 here, that would have worked. Then it would have been negative 1, negative 2. But it's not. All right. What times what is negative 15, but when added together is positive 2? Positive 5, negative 3. 5 times negative 3 is negative 15. 5 plus a negative 3 is positive 2. Does that make sense? Okay. What times what is negative 36, but when added together is positive 9? Nice. Positive 12 and negative 3. That was great. 12 times negative 3 is negative 36. 12 minus 3 is 9. Number 7. What times what is 30, but when added together is 31? Oh, this class is just going to go on fire, man. You guys are great. 30 times 1 is 30. 30 plus 1 is 31. Why would it be 31x? Oh, wait. Yes, this should be an x here. My bad. Thank you, son. Yes, there should be an x there. Please, that's a great correction. Thank you. I should have paid attention. I'm sorry. Very, very good job, son. Yeah, because what times what is 30, but when I think it's 31. 30 times 1 is 30. 30 plus 1 is 31. Okay, what times what is negative 40, but when added together is negative 3? Negative 8 and positive 5. Excellent. You guys rule. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. It's Mickey Mouse, isn't it, guys? Okay, now let's just amp it up just a little bit. Just a little bit. What do you think you always should try to do first? Factor out a GCF. So I'm going to factor out a 5. I got y squared minus 4y minus 32, no? Yeah, 32. Okay, now we have a trinomial. We already know how to at least attempt to factor a trinomial. So let's attempt it at least. Let's see if it can work. What times what, if anything, equals negative 32, but when added together is negative 4? Negative 8 and positive 4. Ding dong, the witch is gone. You're good. Factored. Done. Bye-bye. What about for number 10, guys? Can you factor anything out? A negative 3. Always, if you can, guys, if there's a negative in front of the leading term, factor out a negative always. You always want that first coefficient to be positive. It just makes your life easier. So I'm going to take out a factor out of negative 3. I got x squared plus 2x, bless you, plus 8. All right, y'all. What times what is 8? But when added together is 2. Go ahead. Can't do it. Yeah, it's not that it's prime, it's that this is as far as it goes. And that's it. It's not prime because I did factor out a GCF. But the trinomial, yeah, I cannot go any further. If I can do nothing at all, then it's prime. If I can factor out a GCF, I factor something out. And then that's it. It's as far as I can go. Because nothing times anything is 8, but when added together is 2. Now, if this would have been a negative 2 here, then it would have been positive 2 and negative 4. And that would have had to have been a negative as well, right? See what I'm saying? Okay. Now, next one, guys. Factoring trinomials in the form of ax squared plus b. This is 6-3. This time there's going to be a coefficient in front of the x squared. Now, the good news, it's almost identical to what I just finished teaching. That's the good news. The bad news, the last step is what almost everyone always forgets, and that's what kills them in the test or quiz. So, let me show you how close it is to the procedures we just learned. First step, remember how we did the x and the x? This time, the a that's in front of that x, follow it to both binomials like so. 5x, 5x. Trust me. Just trust me. I know what some of you are thinking, and maybe not in this class, but maybe in the internet world, they're saying, wait. 5x times 5x, that's 25x, Mr. Moore. You're wrong. No, I'm not. Just chill. I promise you, there's a little trick here. So everyone can understand that, right? The same thing you do with the x's, but whatever a is there gets placed in both binomials. Yes, sir. No, in example 9 and 10, I could factor out a GCF. Can I factor out a GCF here? Yeah, if I can't factor out a GCF, I'm going to have an a here in front. Okay, so does everyone understand what I just said? AX, AX. Okay, step 2. You're going to multiply. Please, there's 2 things that are different. This is one of the things. You're going to multiply A times C to find a new C. So that's what I did here. A times C to equal a new C. 5 times 2 is 10. So that is my new C. That is my new C. So my setup, AX, AX. Step 2, multiply A times C and find a new C. Find a new C. You guys with me? Now, step 3, just like before. What times what equals the new C, but when added together equals the B? Yes, sir. Very good, son. 10 times 1 equals 10. 10 plus 1 equals 11. Step 4, just like before, plug in the answers. So I have 5x plus 10 times 5x plus 1. Is everyone with me so far? We have my setup, AX, AX. Then I multiply A times C to find a new C. Then I have step 3, what times what equals the new C, but when added together equals B. Then step 4, I plug those in. Step 5, yes sir. Yeah, you forget about the old C. You're working with the new C now, Papa. Thank you. Now step 5, I call it imaginary factoring. Let me explain what that means, guys. Can't you tell that you have a common factor here of 5? Well, haven't I already trained you that when you factor out a GCF, you put it on the outside, right? Right? That's what I've trained you to do, right? Well, that's why this is called an imaginary factor. You're going to factor out that 5, but you're going to get rid of it. You can't factor anything out of the second term. Sometimes you can, sometimes you can't. So that's your answer. You're done. So let's go from the beginning. Okay? I'll write it out in blue. I have 5x squared plus 11x. My setup, 5x times 5x. Whatever the a is, I keep it. Then I multiply 5 times 2 to give me a new c, which equals 10. Step 3, what times what equals 10, but when added together is 11? Well, 10 times 1 equals 10, and 10 plus 1 equals 11. So I plug those in. I have 5x plus 10 times 5x plus 1. Then I imaginary factor. Oh, I can take a 5 out of here, so I'm going to divide it out. X plus 2 times 5x plus 1. It's an imaginary factor because we know that when we factor out a GCF, we keep it. But this is an imaginary factor. So we get rid of it. It's a trick, and you're done. Sir? If the second binomial can be factored out, you also imaginary factor that one. Yes, sir. Yes, sir. Now, this is called the Cuban method. This is how they do it in Cuba. I'm not joking. Little old guy taught me. He's a cool guy. I have another way for you, though. Because you know that I like to teach you everything that I possibly can. I'm going to teach you now how to do this, y'all, by grouping. Believe it or not. So step 1. This time, step 1 is multiply A times C. So step 1, multiply A times C. 3 times negative 8 is negative 24. That's my new C. Okay? You guys are going to have to choose one method or the other. I don't care what you use. I want you to use the one you like. Step 2. What times what equals the new C, but when added together equals the B? Okay, no, it's negative 12 and 2. Okay? Negative 12x and positive 2x. Because negative 12 times negative 2 will give you negative 24. Negative 12x plus 2x gives you negative 10x. That's what I'm looking for. That's my B. You with me so far? Step 3. Group the two terms with the first and last terms. So take your 3x squared and the negative 12x and take the negative 8 and the 2x. Okay? And then we're going to group them, just like I've taught you. Yes? There is no equal sign. This was just trying to test what times what is negative 24, but when added together is 10x. Okay? And then from here, I can group it. I can group this. I can take out a 3x for my first binomial. I can take out a 2 for my second binomial. And now, I group it. And this should be a times. And that's it. I like the Cuban method better. But that is a personal choice. That is a personal choice. So again, how does the grouping work? Okay, I'll do it in blue. You're first going to go, okay, 3 times negative 8, 8 times C. Okay, I got negative 24. All right. What times what is negative 24? Okay, so sorry about that. So what times what is negative 24, but when added together is negative 10. It's going to be negative 12x and 2x. Why x? Because there's an x here in the middle, so I got to put that there. Then I take my A term and my C term and I combine them with the two terms I just found to make C. So I've got 3x squared minus 12x, excuse me, and I've got 2x minus 8. And now I'm going to group it, okay? I can take a 3x out of here, leaving me with x minus 4, and I could take a 2 out of here, leaving me with x minus 4. And now I factor out the x minus 4, and my leftovers are 3x plus 2. It's just a regular grouping problem. Does that make sense? Just out of curiosity, how many of you guys like the Cuban method? That's what I thought. Okay, it's a lot easier. Let's do it then, guys. Let's do this. I got 3x and 3x. A times C is 6. I'm going to do it by cubic method because everyone likes the cubic method. What times what is 6, but when added together is 5? Positive 3 and positive 2. Can I divide something out of here? A 3. X plus 1. And then I got 3x plus 2. I'm done. Why didn't I put the 3 here? It's an imaginary factoring. Very good. Done. A lot quicker than grouping. A lot quicker than anything. We're doing the same thing in essence. We're doing the same thing in essence, but it's a little bit quicker. Okay? Does that make sense? Okay. Let's do the next one. First of all, can I factor out any GCF? No, not for example 3. So I got 8x. I got 8x. It kind of stinks when they're large numbers like this. That's why you got to know your times tables. What's 8 times 15? 8 times 15 is 80 and 4, 120, right? 120. Okay. So what times what is positive 120, but when added together is 22? Wow, nice, quick. Positive 10 and positive 12. Excellent. I can take out of here a 2, giving me 4x plus 5, imaginary factor style. And I could take out of here a 4, which gives me 2x plus 3, imaginary factor style. I just divide it. I don't show it. Talk to me, guys. Yes, no, maybe, kind of, sort of. Did you guys do this last year? Okay. Was it as awesome as this? And you probably did the first method with trial and error. Yeah, that's a mission. This is a lot easier, no? Good. I'm so happy. I'm so happy, guys. Awesome. Okay, let's see what we got here. I can't take out any GCF, so I got a 6x, and I got a 6x. Multiply 6 times 5, my A times C, to find a new C of 30. What times what is 30, but when added together is 13? Plus 10, plus 3. You guys are awesome. Imaginary factor of 2. Imaginary factor of 3. And that's it. Remember, sometimes you can imaginary factor both of them. Sometimes you can only imaginary factor one of them. But you will always at least imaginary factor one of them. Okay. I can't factor a GCF out of number 5. So I'm going to set up 3x, 3x, 3 times 5. My new C is 15. What times what is 15? But when added together is 16. 15 and 1, you guys rule. I can imaginary factor of 3. So I got x plus 5. And I got 3x plus 1. Number 6, I cannot factor a GCF. So my setup, 2x, 2x. 2 times negative 7 gives me a new negative 14 as my new C. What times what is negative 14? But when added together is negative 13. Negative 14, positive 1. You guys are awesome. Imaginary factor of 2. So I got x minus 7 times 2x plus 1. And last but not least, I want you guys to see them all. Okay. I cannot, bless you, I cannot factor out any GCF. So I have 4x. 4 times negative 3 is my new C of negative 12. What times what is negative 12, but when added together is positive 4. 6 and negative 2. Fantastic. Artificial factor or imaginary factor of 2. So I got 2x plus 3. Imaginary factor of 2. I got 2x minus 1. Y'all are done. Sir, thank you. No, you will always imaginary factor one of them at least. Always. Thank you very much. Great question. Yeah, that's it. Y'all got any questions on that? Yes, sir. Yes, for example 6. Where did I get the negative 14? A times C. 2 times negative 7 is negative 14. That's my new C. And then what times what is negative 14? But when added together is negative 13. Negative 14 and 1. 13 times 1 is not 13. 14 times 1 is 14. Not 13 times 1. Thank you, son. All right, guys, I hope you all learned a lot. Thank you very much. Have a great day.